Good afternoon, this is Mr. McConley and this is BKW General Physics. And today we're going to work on or talk about another type of rate. So we've talked about mechanical rate, and we did a video where we figured out the rate of an ATV. Electrical rate, that was charge, and we also talked about current in amps or coulombs per second. Fluid rate, where we talked about a certain amount of mass or a certain amount of volume in a certain time. And now we're moving on to thermal rate. So thermal rate is thermal, being heat, is the flow of heat. It's how quickly heat is flowing. Now this has a few different units that we can use. It could be in joules of heat, just like you're used to joules of energy. It could also be in calories. Okay. Those are two ways that you can measure the heat. But the thermal rate, if we get right down to that, it's how quickly the heat is moving. So I'm going to jump right to the thermal rate equation, and then we'll backtrack and talk about why heat is important. So the thermal rate equation basically goes like this. Just the same as fluid rate was a Q. The Q still works for this topic. And you're going to take the heat and divide by the time. So this, of course, is heat, either in joules or calories. This is time, which could be in seconds or minutes. And then the flow rate, or the heat flow rate, I should say, would either be in joules per second or calories per minute or calories per second, depending what units you're in. All right, so there's one handy equation, pretty easy to use. It's just a division. But how do you actually get the heat? So let's continue on talking about heat for a second. There actually is a whole nother equation that goes like this. The heat of something is the mass times the specific heat times the change in temperature. So let me clarify what this means. Okay, mass, that's no problem. You're either in something like grams or kilograms or, a mass unit. Specific heat you may not have heard of before, but what it really means is it means how much heat does it take to change the temperature of a material a degree Celsius. So there's all different numbers, and you can look them up online. For instance, in a moment I'm going to do an example here about carbon steel. And carbon steel has a C value, you can see right there, of 0.117 calories grams degrees Celsius. All right, we'll come back to that. But what I'm saying is the specific heat you can just look up. All right? Or you're given this one. And then the temperature, it's actually a delta T, so it's a change in temperature. And it's a change in temperature in degrees Celsius. So what you can do is you can find the heat and then take the heat and plug it in up here and divide it by the time, and you will be able to get the heat flow rate. So let's do an example. Let me get a different color marker here. I'll switch over to the black. And I'm also going to try something else with my camera here. I don't like this. I guess that's working all right. All right. So I looked up some information about carbon steel. So if you had a piece of carbon steel, let's say here it is, just a chunk of steel that I down the basement here. And you were going to heat this up. I'm not really going to do it because I don't have any way to actually take the temperature of this when I'm done. But I take this little propane torch here and I heat this thing up. Then I could figure out the heat flow rate. So let's go ahead and do that. So let's write down our facts here. The first thing we would want to do, step one, we would want to calculate MC delta T for this specific example. Now I mass this, comes out to be about 2,000 grams. As I said before, I looked up the specific heat. It's 0.117 calories over grams times degrees Celsius. And the change in temperature, I'm going to heat it from room temperature 30 degrees up to 60 degrees. So change in temperature would be 60 degrees minus 30 degrees, or if you're paying attention, you could have just put a 30 in there. So we're going to have 2,000. We're going to times it by 0.117, and we're going to times that by 30. Okay, so let me get my handy dandy calculator fired up here, and we'll see what this gives us. All right, here we go. So we go 2,000 times 0.117 times 30 will give us 7,020. What are the units on this? Well, let's go back up here. The grams canceled with the grams because one was on the top, one was on the bottom. The degrees Celsius canceled with the degrees Celsius. So what I'm left with at the 7,020 is calories. That's a measure of heat, like I said earlier. All right, let's finish this problem off. Well, what if when I was heating it, back to the heating here, when I was heating it, it took me 330 seconds to change the temperature to 30 degrees. What would be the heat flow rate? So Q equals H over T. I got 7,020 calories, and I'm going to divide it by 330 seconds. I'm just pulling these numbers out of my hat. I don't really know how long it would take to heat that up. But back to the calculator, I take the 70/20, I divide it by 330, and I get 21.3 calories per second. This is the thermal rate, or the heat flow rate. So I've shown you how to find an amount of heat, then find a heat flow rate. So to follow up on this, I'm going to give you a couple problems where I'm going to give you some numbers, give you a couple days to try these out, and I'm going to have you use the same technique that you've just learned right now. For today, this is Mr. McConley, BKW General Physics.